Today in Capecchi's Corner, we have a review lesson that includes linear functions and the equations of linear functions. We are asked to find the rate of change of the given line. Now, the rate of change is the same as the slope. When we're finding slope, we do rise over run. When I'm finding rise over run, I like to start with the point to the left. And if I need to get to my second point by going up, my numerator would be positive. If I need to go down to get to my other point, then my numerator would be negative. Then I'm going to move right or left, my run. If I move to the right, then I have a positive value. If I move to the left, then I have a negative value. So when counting my slope, I go from the point to the left and I go my rise. And I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So my numerator is going to be positive 9 because I went up. And then I go to the right, 1, 2, 3 to hit my second point. So when I go to the right, it's positive. So I have 9 over 3, which simplifies as 3. So my slope or my rise over run or my rate of change has the value of 3. We are asked to find the slope of the line that passes through the points negative 6, 4 and negative 6, 2. So I'm going to label these. This is going to be my x1 value and this is going to be y1. And my other point is going to be x2 and y2. And I'm going to use that in my slope formula, which is slope is equal to y2 minus y1 over x2 minus x1. So that gives me the rate of change or the slope. So I have the slope is equal to 2 minus 4 over negative 6 minus the negative 6. I clean that up and I get negative 2 over negative 6 plus 6, which is negative 2 over 0. Now I can't have a value over 0, so that has an undefined slope because that number is actually undefined. If you put that in your calculator, it will tell you an error or a divide by 0 error. Now remember, if something has an undefined slope, we've talked about this in previous lesson, then it's considered a vux. It's a vertical line with an undefined slope, and my equation is x is equal to a number. Now in this case, if you notice, both my x values are equal to negative 6. So the equation of this line that passes through that given slope has an undefined slope, and it also has an equation of x is equal to negative 6. We are asked now to find the rate of change represented by the given table. So I have a table, and I have some x values and y values. Each of them are actually an ordered pair. So I have negative 2, 3, I have 0, negative 3. I also have 4, negative 3. So these are all points that could be found on the line. So I'm going to use my slope formula, which says m is equal to y2 minus y1 over x2 minus x1, and I can use any 2 points. So if I use the first 2 points, I have the slope is equal to negative 3 minus a negative 3. And then when I'm using my x values, I have 0 minus a negative 2. So when I clean that up and simplify, I have negative 3 plus 3 over 0 plus 2, which simplifies to 0 over 2. So the slope of 0 over 2, that simplifies to 0. Now remember, a 0 slope, we call that a hoy because of the 0. It's a horizontal line because it has a 0 slope, and also has equation of y is equal to the number. Now, if you look back at the table, all my y values are equal to negative 3. So if I wanted to go further with this problem, I know that the slope is 0, I know it's a horizontal line, and I know the equation of the line is y is equal to negative 3. We are asked to find the value of r so that the line passes through the points 10, 7, and r10. Remember, r is our unknown that has a slope of negative 1/2. So what I'm going to do is I'm going to use my slope formula, and I'm going to set that up. So I have negative 1/2, that's my slope, is equal, remember, to y2 minus y1. So I'm going to take 10 minus 7 over x2 minus x1, so that's r minus 10. And I'm going to clean that up a little bit. So I have negative 1/2 is equal to 3 over r minus 10. Now I'm asked to find the value of r, so I'm going to cross multiply. So I'm going to take 2 times 3, which gives me 6. And then I'm going to do the reverse on the other side. I'm going to take negative 1 and multiply that by r minus 10. And then I will distribute. So I have 6 is equal to negative r plus 10. There's my wall. I want to get r by itself. So I'm going to subtract 10 from either side. I have negative 4 is equal to r, negative r. So I know if I divide both sides by negative 1, then r has a value of 4, which is my final answer. Now I always like when I can check things in math, so I'm actually going to substitute that back in to my original coordinates. So I have 10, 7, and I have 4, 10, and I want to use a slope formula. So I have 10 minus 7 and 4 minus 10. So that gives me 3 over negative 6, which is negative 1/2 as the slope. And if I look, I'm actually given negative 1/2 is my original slope, so I know that I did this problem correctly and that r has a value of 4. The problem states to write the equation in slope-intercept form. So here's my slope-intercept form. Y is equal to mx plus b. Remember, m is the slope and b is my y-intercept. So all I have to do is get y by itself. So in number 1, there's my wall. I have my y value on the left-hand side, so I need to move my x to the other side. So I have negative 3y is equal to negative x plus 4. So I have negative 3 times y. So my opposite operation there is divide. So I'm going to divide everything by negative 3. So I have y is equal to, now I have negative 1 over negative 3, which gives me a positive 1/3 x. And then I have minus 4/3. So that's my first equation in slope-intercept form. I'll do the same thing with number 2. There's my wall. I want to get my y by itself. So I'll do the opposite operation, add 2x to both sides. I have negative 4y is equal to positive 2x plus 14. Divide both sides by negative 4. And I have y is equal to, and I need to simplify this, negative 2 over 4. So that gives me negative 1/2 x minus, and again I can simplify 14 over 4 gives me 7 over 2. So my equation in slope-intercept form there is y is equal to negative 1/2 x minus 7 over 2. We're asked to write an equation of the line shown in slope-intercept form. Now remember, slope-intercept form is y equals mx plus b. M is the slope, and b is the y-intercept. So if I can just find those two things, I can certainly write the equation of the line. So let's start with my y-intercept. That's always the easiest. My y-intercept there is negative 3. That's where it hits the y-axis. And then I'm going to do my rise over run. Now I notice bottom left to upper right is a positive slope. So that's one way I can double check. So I start with the point to the left and I go up 1, 2. So my rise is going to be a positive 2. And then I'm going to go to the right. 1, 2, 3. So to the right 3 is a positive 3. So when I use my equation, the equation of this line is y is equal to 2/3 is my slope, x minus 3. So that's the equation of my line in slope-intercept form. We're going to write another equation of a line in slope-intercept form with a new graph. So I have my y-intercept is positive 1, so my y-intercept is positive 1. And my slope, I'm going to start with my point to the left, and this time I have to go down 2. So when I go down 2, my numerator is negative 2, and then I go to the right 1 to get to my other point. So right is a positive 1, so my slope is negative 2. So my equation of the line is y is equal to negative 2x plus 1. In this problem, we're going to practice graphing. So we have y is equal to 3x plus 2. So that gives me the y-intercept of positive 2. And then my slope is 3, or 3 over 1. So because my numerator is positive, I'm going to go up. Because my denominator is positive, I'm going to go to the right. So I start with my y-intercept, which is positive 2. And then I'm going to go up 3. 1, 2, 3, and then to the right 2. And get that point. I'm going to do one other point. I'm going to go up 1, 2, 3. To the right 2. Now I'll connect my points, and then I will draw arrows on the end, and there's the equation of my line. Now we're ready for a word problem. It says a rental company charges $8 per hour for a mountain bike rental plus a $5 fee for a helmet. Part A says write an equation in slope-intercept form for the given situation. And then part B says, what is the total cost for renting a mountain bike for 3 hours? So let's go back to the beginning. It says a rental company charges $8 per hour. So that's my rate of change. For every hour, I'm going to pay an additional $8 for a mountain bike rental plus the $5 fee for a helmet. So my $5 fee is my constant. That's what I'm going to pay no matter how many hours that I rent. So in part A, my equation is y is equal to my slope or my rate of change is 8. I'll take that 8 and multiply it by x, that's going to be the number of hours, plus $5 fee, that's my flat fee, that's my constant fee that I'm paying for the use of a helmet. Now we're ready for part B. It says, what is the total cost for renting a mountain bike for 3 hours? So I have y is equal to $8 an hour. My x value was the number of hours, so I'll multiply that 8 by 3, and then I have plus $5 for that helmet. So I have 24 plus 5. So my total cost for renting a mountain bike for 3 hours is $29. Now we are asked to write the equation of the line that passes through the given points. So I have 2 points. I have -4, 3, and I have 1, 13. Now, since neither of these points are my y-intercept, I need to use the point-slope formula. So that formula is y minus y1 is equal to m, which is the slope, times the quantity of x minus x1. So the first thing I have to do is I have to find the slope. So I have m is equal to, and I'll take 13 minus 3 over 1 minus a -4. So that gives me 10, and then 1 minus a -4 gives me 1 plus 4. So I have 10 over 5, which simplifies to 2, so my slope is 2. Now, when using my point-slope formula, it does not matter which point I use, so I'll use the first one. So I have y minus 3 is equal to 2, which is my slope, times x minus a -4, so it's going to give me x plus 4. So now I need to distribute so I can get rid of my parentheses, so I have y minus 3 is equal to 2x plus 8. And I'm going to add 3 to either side because I'm trying to get my equation in slope-intercept form. So I have y is equal to 2x plus 11. So that is in slope-intercept form right there. At this line, that is my point-slope formula. Now the point-slope formula we can't graph in. That's really just an equation of a line that helps us get to our slope-intercept form. I say point-slope form is a working equation to help us get to slope-intercept form. I have another problem that's asking me to find the equation of a line that passes through the given points. So I have 2 points here. If I'm not sure whether one of the points is a y-intercept, I can just kind of do a quick sketch. So I know 2, 3 is going to be over 2 and up 3, so it's going to be somewhere in here. And I have 0, 8, so 0 is here, that's my x value, and I know I'm going somewhere on my y-axis, so I do know that that is my y-intercept. So because of that, if I can just find the slope, then I can go right to slope-intercept form. So if my slope is equal to 8 minus 3 over 0 minus 2, so then my slope is 5 over -2. So my slope is -5 over 2, and then my y-intercept is 8. So my equation of my line in slope-intercept form is -5 over 2x plus 8. Now, students often ask, is it okay that my negative sign was here when I calculated my slope as it was in my denominator? I change it to the numerator, which is fine. It still has the same negative value. I'm again asked to find the equation of the line that passes through the given point. So I have 5, 3 and 5, 13. So neither of them, I notice, are the y-intercept. So first I'm going to start with the slope. So I have 13 minus 3, and then I have 5 minus 5, which gives me 10 over 0. Now 10 over 0 is an undefined number. So we've talked about this early. That means it's an undefined slope. So I know it's a vux. It's a vertical line with an undefined slope, and my equation is x is equal to a number. So I need to figure out what number that is. Well, if I go back to my points, I notice that each x value has a 5 as its x-coordinate. So my equation, that line, is going to be x is equal to 5. It's a vertical line. We have one more problem like this where we're still writing the equation of the line that passes through the given points. Again, I notice that neither of them is the y-intercept. I'm first going to find the slope, so I have 3 minus 3 over 1 minus a -4, which gives me 0 over 1 plus 4, so that's 0 over 5. Now 0 over 5 has a value of 0, so my slope is 0. That is a Hoy, 0 slope. It's a horizontal line, and I know my equation is y is equal to a number. So I go back to my given information, and I notice that my y-coordinates in both points is 3. So the equation of that line is y is equal to 3. Now we're ready to move on to standard form. So we're going to write the equation of each line in standard form. Standard form is ax plus by is equal to c. And there's a few things that are important there. My x and my y are on the same side of the equation, where my constant or my c value, my number by itself, is on the other side. My a value is always going to be positive, and I'm not going to have any fractions or decimals in standard form. So let's look at number 1. So here's my wall. I notice that my x value is on the right-hand side. My a is in front of it, so it's a positive 1. So I know that I'm okay leaving my x value to the right-hand side because it has a positive coefficient. So I'm going to bring y to the other side. So then I have 0 is equal to x minus y plus 3. Now I have my x and my y on one side of the equation, but I now need to move my constant to the other side of the equation. So I'm going to do the opposite operation. I subtracted 3, so I have negative 3 is equal to x minus y. And a lot of times you see the x and the y on the left-hand side, so I'm just going to rewrite that as x minus y is equal to negative 3. So that's my final answer for that equation in standard form. Now I'll do the same thing with number 2. I notice in number 2 I have fractions, and I can't have fractions in standard form, so I want to get rid of that first. I notice that my denominator is 3, so I'm going to multiply everything by 3. So 3 times y gives me 3y is equal to 3 times negative 1/3, which gives me negative x, and then 4 times 3 gives me 12. So I multiplied each term by 3. Now again, here's my wall. I want my x and my y on the same side. In this case, my x was negative, so I want to move that to the other side. So I added x to both sides. So I have x plus 3y is equal to 12. So before I say that's my final answer, I want to double check a few things. My x and y are on one side, my constant's on the other side, my a value, or my number before my coefficient, is positive, and I don't have any fractions, so there's my final answer. X plus 3y is equal to 12. We're going to do some more work in standard form. So I want to write this equation in standard form. So the first thing I want to do is my order of operations, and I want to get rid of my parentheses. So I'm going to distribute, so I have y minus 3 is equal to 5x minus 10. Now, there's my wall. I notice my a value, which is my coefficient right before my x, is positive, so I'm going to leave that there. I'm going to bring the y to my other side. So I have negative 3 is equal to 5x minus y minus 10. Now I need to bring my constants all to one side, so I'm going to add 10 to both sides. So I have 7 is equal to 5x minus y, and I usually see the 5x, the x and the y on the left-hand side. So I'm going to rewrite that. So I have 5x minus y is equal to positive 7. So that is my equation in standard form. Now we're shifting gears a little bit. The question says write the equation of the line in slope-intercept form that passes through the given point and is parallel to the graph of the given equation y is equal to negative 2x minus 6. So what that means basically is I have this line, and then I have a point outside the line. So what I'm trying to do is find an equation of the line that passes through that point and is parallel to my first line. So I know parallel lines have the same slope, so that's the piece of information I need. So I'm going to keep the point that I was given, negative 4, 1, and my slope of my given line was negative 2. So the slope of my new line is also going to have the same slope because they're parallel. So I have a slope, and I have a point that is not my y-intercept, so I'm going to use point-slope formula. So I have y minus 1 is equal to negative 2 times the quantity of x plus 4, or x minus a negative 4. And I'll distribute, so I have y minus 1 is equal to negative 2x minus 8. I'll add 1 to both sides. So I have y is equal to negative 2x minus 7. That's the equation of my line in slope-intercept form that goes through my given point and is parallel to my given line. We have a similar problem here, but this time we're talking about perpendicular. So it says write the equation of the line in slope-intercept form that passes through the given point and is perpendicular to the graph of the given equation. So here's my point. Now my original line has a slope of negative 3. So basically, again, what that's saying is I have a line and I have a point. And what I want to do is I want to find the equation of this dashed line that goes through my given point but is perpendicular to my given line. Now, perpendicular lines have slopes that are opposite the reciprocal. So what that means is if my given slope is negative 3, I'm going to take the reciprocal, which is 1 over 3. Remember, I just switched my numerator and denominator, and I take the opposite sign. So my original line has a negative slope, so my new slope is going to have a positive slope. So my new slope is going to be 1/3. So I have my slope and I have my given point, which is not my y-intercept, so I'll have to use point-slope form. So I have y minus 4 is equal to 1/3 times the quantity of x minus 2. I'll get rid of my parentheses, so I have 1/3 x minus 2 over 3 when I distribute. I add 4 to both sides, and I have y is equal to 1/3 x, and then I have negative 2/3 plus 4 simplifies to 10 over 3. So there is my equation of my line that passes through the given point and is perpendicular to my given line. Now we're going to graph some equations. So I have x is equal to negative 3. So again, that is a vux. I have x is equal to a number. I don't have a slope there because it's undefined, so it's a vertical line. So what I need to do is I need to find the value of x is equal to negative 3 on my graph, which is right here. And then I'm going to draw a line right through that, and that will be the equation of my line. So I have x is equal to negative 3. I'll put arrows on the end. So that's the equation of my line, x is equal to negative 3. Now I'll do the same thing in blue. I have y is equal to 4. So again, I don't have an x value. I have a 0 slope here. So my y, remember, is a hoi. So that means I have a horizontal line with a 0 slope. Y is equal to the number 4. So I'm going to do the same sort of thing. I'm going to go up 4 on my y-axis to get y is equal to 4. And then I'm going to draw a line that's going to go through y is equal to 4. And I will put my arrows on the end. And that is my equation of y is equal to 4.